In this video, we'll discuss counting the number of outcomes in probability. Now, let's start with a couple definitions to help us along. First, a multi-stage experiment is one in where several experiments are performed in a row. For example, if we had a game where we first rolled a die and then spun the spinner, that would be a multi-stage experiment. Now, within these multi-stage experiments, it's important to recognize whether the events are independent or dependent. An independent event is where no event in the experiment influences the possible outcomes of the other event. For example, when I roll the die, that does not change the color in which a spinner lands. So spinning the spinner and rolling the die are independent of one another. So that would be an independent experiment. Whereas if it's dependent, one event will influence the possible outcomes of the other events. So what would be an example of this? Say we have a bag that's full of marbles, and there's 3 blue, 5 red, and 2 yellow in the bag. I reach into the bag to pull out a marble, and it comes out as blue. I'm going to set that on the table. Now think about what's left in the bag. There's now only 9 marbles in the bag, 2 blue, 5 red, and 2 yellow. Since there's only 9, the probabilities of choosing each of those colors changes just by a little bit, but they have changed. Thus, the second draw is dependent upon what was drawn first. Now, one of the key parts to understand how to count is the fundamental counting principle of independent events. Here, if one event can occur m number of ways and the second event can occur n number of ways, the number of ways of the two events occurring would be a sequence of m times n. Let's look at an example and go back to our dice and our spinner. But it's also important to realize that as we do this, using a tree diagram will help us create the entire sample space beyond just knowing how many events occur. So with the die and the spinner, if I think about the die first, there's 6 options, 1 through 6. With this specific spinner, there's 3 colors, red, green, and yellow. That means that there are 6 options times 3 options, which is 18 total outcomes for this event. Now you may be asking yourself, what would that look like? And this is where creating the sample space can be helpful. So let's start with the first event, which is rolling the die. If I create a tree diagram, I'm going to create from the center 6 branches. 1, 2, 3, 4, 5, 6. And from each of those will come the outcomes of the spinner, which would be the red, green, and yellow. And if I look at all of those options, I would have 1 red, 1 green, 1 yellow, and I'd keep going. There will be 18 total options. Now, what about if the events are dependent? What you have to consider is how does event 1's outcome impact the number of options in event 2? It could be that the total of the entire event changes, or it could be that each individual event within there could be modified as well. So when we finish understanding how those different events are modified, we do the multiplication of the number of ways of each, just like we did for the independent events. For example, say that we have 10 students that want to run for president and vice president, and we know how many combinations are there for those 2 positions. So first start with, how many could be president? Well, there's 10 students, so there's 10 students available. Well, once the president is chosen, how many could then be the vice president? If the president is gone, that leaves me with 9 students available, because you can't be both president and vice president. That means that the total number of possibilities will be 10 times 9. That's the dependence. The vice president was dependent upon the president. Now, what if there were more than 2 events that occurred? First, ask yourself, are the events independent or dependent of one another, because that will influence the number of outcomes. But just like before, we're going to multiply the number of outcomes for each event, whether that's multiplying 2 numbers, 3 numbers, 4 numbers, or however many there are for the total number of events in the multi-stage experiment. Let's go back to our idea of the 10 students running for office, but maybe now they're running for president, vice president, secretary, and historian. How does that change the total number of combinations? First, again, start with the idea of how many could be president. Well, we start with 10 students. But when we go to vice president, one student is already gone. That means there's now 9 students available for vice president. When we get to secretary, we've already chosen a student for president and a student for vice president, so there's only 8 students available for secretary. And then if we think about for historian, we've chosen 1 for president, 1 for vice president, 1 for secretary, so there's only 7 students available to be historian. So then when we want to know the total number of combinations, that's 10 times 9 times 8 times 7, which is 5,040 different combinations.